Hello grade 12s. This is the second video in our series on momentum. Now let's quickly mark the two questions that was given as an assignment at the end of the previous video. A tennis ball of mass 60 grams travels with a velocity of 1,2 meters per second left. A tennis racket hits the ball, whereafter the ball travels with a velocity of 2.1 meters per second to the right, and you have to calculate the momentum of the ball before the tennis racket hits the ball. Okay, so what we've learned, the first thing that we need to do is choose our direction. You can either choose to the left or to the right as positive, but once you made your decision, stick to that decision throughout the problem. So I'm going to choose to the left as positive, then I write down the equation that I need to solve this problem, which is P, momentum is equal to mass times velocity. I substitute my values. Remember 60 grams I have to convert to kilograms, so that's 0.06. I chose to the left as positive. The ball is traveling to the left at 1,2 meters per second, so I have a positive value there, and that will give me a positive answer. But I have to interpret the sign as far as the direction is concerned. So I don't write plus or minus my answer. I just write the answer, and then the sign I interpret as the direction. So since this one is positive, I know my direction is to the left. I get a lot of sums in the exams where people forget the unit and they forget the direction. So make sure that you practice this a lot. Okay, and if we calculate the momentum of the ball afterwards, it's pretty much the same story. First, I choose a direction. Stick to the direction in a problem that is continuously in the same for all the different sums in a specific problem. In the previous one, 1.1, I chose left to be positive, so I'm going to stick to that, and therefore this ball is now traveling to the right, so it's going to have a negative velocity. I write down the equation that I use, I substitute the values, I converted my mass. My velocity is now a negative number because it's moving to the right. And then if I calculate that, this will give me a negative number, but I cannot keep the negative number in my final answer. I must interpret that negative sign as a direction. So my final answer will be 0,126 kilograms meters per second to the right. Okay, then they also asked me to draw vector diagrams for these momentum representations. Now, momentum is a vector, and a vector is represented by an arrow. The length of the arrow represents the magnitude, and then the direction of the arrow will be the same as the direction of the momentum. So my momentum beforehand was to the left, so my arrow points to the left, and the length will represent 0.072 kilograms meters per second. The length will be drawn to scale according to the magnitude of my vector. If I look at 1.4, this one will be slightly longer than my previous vector. It's got a value of 0.126, and it goes to the right. Okay, so that is my homework sums. And let's quickly summarize what we know about momentum. Momentum of an object is big when it either has a large mass. So if I have an elephant running forward, that will have a large momentum, even though an elephant can't run very fast, so my velocity won't be that great. Or if I have a bullet traveling from a gun, the velocity of that bullet will be quite high, although the mass of that bullet will be quite small. So both mass and velocity influence the size or the magnitude of momentum. Then if I have a stationary object, that's an object standing still, it has no momentum, because then my velocity will be equal to 0. P equals mv, so my total momentum is 0. Okay, I quickly prepared a class test that you can do while watching this video. Please don't just go through this video and look at me passively explaining this. Pause the video when I request this. Do the sum, train your brain. I have passed my grade 12. I do know what's happening in momentum, but you don't. So it's important that you update your knowledge as well. Okay, so let's quickly look at this sum. I want you to compare the momentum of a car and a motorcycle. A motor car has a velocity of 13.5 meters per second north on a straight road, and the mass of the car is 1,300 kilograms. Then I have a motorcycle that goes at a velocity of 30 meters per second. You can see the velocity of the motorcycle is much greater than the velocity of the car, but the mass of the motorcycle is much less than the mass of the car. The car has got a mass of 1,300 kilograms, whereas the motorcycle only has 350 kilograms. You need to compare these two momentum, so you need to figure out which one has the greatest momentum. That is not easy to see at first. You have to do the calculation. Okay, so I want you to start with the momentum of the car. You can pause this video and remember the 4 steps that you use to do the calculation. Choose your direction. Step 1, step 2, write down the equation. Step 3, substitute. Step 4, remember to interpret the direction, the signs in your answer as a direction. Quickly calculate the momentum of the car. And pause this video first, do it on paper, and then continue. Okay, I really hope you paused the videos and did calculate the momentum of the car. So let's quickly see how this works. Well, I decided to choose north as positive since they're moving north. I write down my equation, I substitute my values, and then I find 17,550 as my answer. You will be surprised how many times I see this in the exam with no unit and no direction, and then there follows no marks. Very important that you put in the unit, kilogram meters per second, as well as the direction which I get from the sign. This is a positive value. I chose north as positive, so I know that the direction must be north. Now calculate the momentum of the motorcycle. Pause the video, quickly do it, and then I will do it right after this. Okay, the momentum of the motorcycle. First I choose a direction, stick to the same direction in a specific problem. Choose north as positive. I write down my equation, I substitute my values, and then I calculate my answer. I remember my unit, and I remember to interpret the sign as a direction. So now you can see the momentum of the car is 17,550 kilograms meters per second, whereas the momentum of the motorcycle is 10,500 kilograms meters per second. So I can see that my momentum of the car is much greater than the momentum of the motorcycle. Okay, let's look at the following concept, change in momentum. I think it was back in grade 10 when you did acceleration. You defined acceleration as the change in velocity divided by the change in time. And as soon as you talk about change of something, you represent that with a delta or a little triangle. Can you remember that? And that triangle represented the final value minus initial value. So if I talk about change in momentum, I can represent that with a triangle P, which means in a situation my momentum will change. Now if you look at this hockey player that I have over here, the hockey puck has an original velocity when it travels in this direction, and then the player kind of helps it along so that it has a new velocity. So the momentum of the hockey puck is changing, and if you have to calculate that change in momentum, you will take the final value of the momentum and subtract the initial value. Now let's look at a problem that we have down here. A hockey puck with a mass of 700 grams moves at a velocity of 22 meters per second to the west before a hockey player hits it. Thereafter, it moves with a velocity of 40 meters per second to the west, and you have to calculate the change in momentum. Always when we do with momentum sums, we start with our direction first. So, I'm going to take away the picture just because this continuous motion might distract you, and then you struggle to concentrate on the solution. So let's choose a direction. Choose west as positive since this puck is only moving west. I write down my equation. It's final momentum minus initial momentum. Momentum is mass times velocity, so it's going to be the mass times the final velocity minus mass times initial velocity. If I substitute the values, I need to convert the grams to kilograms, so I have 0.7 kilograms. My final velocity, my velocity in the end, is the number that I have first, and from that I subtract my velocity at the beginning. Okay, so this is going to be plus 22 because it's also going west. This one is going west. Both of these values are positive. This negative number comes from this equation that tells me I have to take this minus that entire number. And then I get a positive answer of 12,6 kilogram meters per second. And because it's a positive answer, I know my answer, my direction must be west. Let's look at this different example. A motor car with a mass of 700 kilograms and a velocity of 100 kilometers per hour hit a lamppost. Now, I've deliberately included units in kilometers per hour because you that drive in motor cars know that when we talk about motors or motor cars, we usually talk about kilometers per hour. However, kilometers per hour, we cannot use that in a calculation. So we have to convert kilometers per hour to meters per second. I did not go into the conversion in this sum. I'm just quickly going to tell you, in order to convert kilometers per hour to meters per second, you divide by 3.6. If you really want to know how and why this is done, you can either send me a message or ask your teacher. But I'm not going to focus on that now. I just want to make you aware of the fact that whenever they post kilometers per hour, you must convert that first. Okay, so a motor car with a mass of 700 kilograms and a velocity of 27 meters per second hit a lamppost. After the collision, it continued north, but now its velocity is decreased to 11 meters per second. And you have to calculate the change in the momentum of the car. So what do we do? First momentum sums, choose a direction. Since this guy is going north, let's just choose north as positive. Then we write down our equation, P final minus P initial. You can write in the exam any one of these two equations. Any one of them will give you marks. You can write them both down as well if you want. Maybe the second one is safer because it tells you which numbers you have to substitute. So I have my final velocity at the end, which is 11, minus the mass times my initial velocity. I said final velocity, but you know I mean times the mass over here as well. Okay, can you see that I'm taking a greater number and subtracting it from a smaller number? Can you see that my answer is going to be a negative number? If you calculate that on your calculator, you will find the answer as minus 11,200. What do I do with that minus sign? That is correct. I interpret it as a direction. It is given as an indication of direction. So I don't leave the answer as 11,200 or minus 11,200. My final answer must be the positive number 11,200 and in the direction mentioned, which is south. Okay. Quickly see if you're able to calculate a change in momentum. So do number 2 on your worksheet and we will mark that in the next video. Good luck.